Check. Check. Is it the right volume? Check. Cool. I think we're good. Gonna share this so hopefully some people see it, and then let's start. Can you share to just my page? No? Is that impossible? Jeez. God damn it, Facebook. Is it literally impossible just to share to your own page now? Maybe it is. I think it's working. Yeah, hopefully the mic is actually working now. Sec, and then let's begin. Playing some background music, so I'm wondering if we're gonna get zooked immediately. So Twitch is running at the same time, and we can run there if everything breaks and stops working. Whee! Finally worked out how to share to my own profile. Boom. Cool. Yeah, so turns out I use this thing called loopback to get all the audio into OBS in various ways, and turns out that's just a really bad idea, because as soon as you open up Ableton it disables the mic working, no matter how much clicking around you frantically do to try and make it work. Which is great news. But yeah, so I think it's time to begin. Let me know if the music gets too loud or anything like that, and I'll try and sort it out. So, gonna be rambling a bit about granular audio effects and Max for Live. I did program something like this a little while ago. So every month in Bristol we run the Bristol Patching Circle, where we get together and we program stuff from scratch in like 2 or 3 hours, different ideas, granular synthesis, Euclidean sequences, data sonification, some of the stuff we've done over the last few months. This was something we did in a kind of class or session not too long ago. But to be honest, I haven't really looked at that to refresh myself. So we're going to be going totally off the cuff and trying to program it from scratch. So I guess this isn't going to be kind of a well thought out, organized tutorial where you're going to like learn a really condensed amount of knowledge quickly. It's going to be hopefully working through some stuff, taking questions, running into issues, showing how to solve issues when you hit them, kind of all from scratch. So yeah, granular audio effect. A lot of you are probably pretty familiar with grains and granular stuff. But obviously great fun to make audio effects or synths, triggering tiny little grains of audio to make really dense clouds of texture and stuff. There's loads of devices that do it, but it's not actually that tricky to get one made up in Max for Live. So I think we can probably knock one up, hopefully within an hour, 2 hours max. Yeah, so I think for now, because it's going to be a Max for Live audio effect, we'll start with it being an audio device rather than it being a MIDI device, although later on might have a mess and add triggering from the keyboard and getting audio in other ways, although that's still a bit fiddly to do. In Max you have to use the Live API and stuff. But for now, let's start from scratch. So I'm going to grab a blank audio effect. And this should start us off in a totally clear, clean patch. So yeah, I've just got these little template devices, just because they have the nice grid settings and stuff like that I like. Let's chuck this over here, chuck this over here. Boom. Cool. So we're now in Max for Live land. This is a pretty basic default patch. I've just added a little bit of generic code and coloring and grid size stuff that I like to use. So if we're going to be making a granular audio effect, we're obviously going to need to get audio in. We're going to need to send audio out. So luckily with the default device we've got the plug in and plug out audio, which grabs audio from the place before the audio effect and sends it out just afterwards. We're going to want to store that audio in some kind of buffer. We could have a kind of sampling button to trigger sampling at specific points, or I'll probably just make it with a kind of rolling audio buffer being recorded continuously, and we can just granularize and glitch up that audio when we like. Could add like loading in specific samples later. That definitely make it more of a kind of traditional granular synth that you probably want to trigger with MIDI rather than just spit audio into and make some weird textures. So I think we're going to start by breaking this connection here. So that's the audio coming in from Ableton. So I could kind of plug in I'll mute this for a sec. Get the audio from my voice as well. And if I just make a quick meter object. Ooh, don't do that. We should see the audio coming in to max. Check, check. Cool. So I do actually have a little thumb piano ready. That's pretty typical granular fodder, and some weird shakers and a few other bits we'll mess around with later. So cool, the audio's coming in. For granular, not going to mess around with making it stereo. We're just going to get a mono sample or the sample to mono, and then we'll probably do some panning, nice stereo stuff later on, where the grains are being triggered left and right to give them a nice kind of panning effect. What I am going to do quickly is hopefully find a way to mute the microphone from my headphones, because it is really weird hearing my voice a second later. But I think because loopback broke, there's probably no way for me to actually stop that, because it's all going through Ableton. Yay! Tell you what. Hello, Mike. Sorry, I'm being very silly. Yeah, because loopback broke and it won't get it individually, I'm having to run it through Ableton so you guys can hear it. And unfortunately, I'm having to hear it at the same time, but slightly delayed, so it's probably going to make me talk a bit weird. But we'll just have to get used to that, I guess. Back to it. So, in Max to record audio, you have the record tilde object. So we're going to use that to grab the audio. I'm going to make a buffer object. So this is like a little object in Max that stores audio onto your RAM so you can access it quickly and kind of mess around with it a lot quicker than files loaded from your hard drive. What next? Cool, so using this kind of classic pairing of buffer, which stores audio into RAM, and a record object, which is going to record the audio into that buffer, and then finally we're going to have the other object of your kind of standard audio recording playing trio. So the buffer object stores audio into RAM, so it has a little, you can kind of decide how long it's going to be, stuff like that. So I think samples, size, let's store 5,000 milliseconds of audio, so that's 5 seconds of audio. And now if we name our good idea, Ned. One ear off, one ear on. That is a little bit better, actually. It's going to stop me slurring my words in a weird way until I can figure out this weird loopback stuff. So yeah, we've got a buffer object, 5,000 milliseconds long. So that's 5,000 seconds of audio, so we can use that as a nice rolling buffer. I gave it the name, so the first parameter of every buffer object, of any buffer object, is the name. I labelled it --_ record, and that's basically giving it a name, kind of universal name, so any other object in Max will know what to look at and can get data from the same object or buffer and kind of mess around with that audio. The --_, 3 hyphens in a row at the start of a name you're defining in this kind of Max global namespace in programming speak. That generates a random number in each device. So whenever I create a new Max for Live device, it gets given a random generated number. And if you use --_ at the start, then basically it generates a random number, and this is limited to just this device. So if I wanted 4 granular engines at the same time and I wanted to drop 4 on different tracks, having this --_ would make sure they're not all using the same audio buffer. Of course, if you wanted to do some weird surround sound thing, multi-channel thing, you can have the same audio buffer and access it from multiple channels. Just in this case, we're going to make a single channel audio device. We only want to, each device should be its own individual thing without other devices messing with them. So we've got the trio of record to record audio, buffer, which is a nice space in RAM where all this audio is being stored, and then we have the play object, which we're going to use later on to design the kind of synth-y engine where we're going to be playing back grains from. So I'm just going to shove the audio straight into the input of the record object. You can open up help files for any Max objects by holding Alt and clicking on them, or right click, open help file, and Max has really nice help files with loads of good info in them, and you can just copy and paste the examples. But yeah, for this granular thing, I think it's probably going to be fun just to have a rolling buffer of kind of audio. So maybe we're going to turn loop on, which is going to make the recording just continually loop around this 5-second buffer. So using this message box with the $1 just means anything I spit in the top gets. Just going to send the message loop on and off to this record object to start it recording. Well, I normally use prepend objects because it's a bit... For some reason I don't like these message box objects. I don't know what it is. They feel weird to me. I think it was years ago someone told me using graphic user interface objects can slow down a patch, so I tend to never use these message box things, so yeah, let's sack that off. I'm pretty sure that's not even an issue anymore. Anyway, this is why it's called mere rambling about Max, not mere giving concise, useful information all the time. Yeah, so we're going to be able to loop this buffer and turn looping on, and then finally we want to be able to just turn the record on and off. Oh, and you literally just send it a toggle to do that. One more toggle button, and that is literally just going to turn the recording on and off. That's kind of all we need for now. We could also make a nice waveform object, so we can see our waveforms. Is the first object not the name? Or is it an attribute? 28 attributes. That is a lot of attributes. One of these better be sample. Screw it. Let's have a look in the inspector window instead. So we are going to set this to look at the record buffer. And now if I do something like blah 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 blah. Yep. We have a buffer filled with whatever random stuff I am talking about at the time. And it's kind of that simple to get audio and record it. So there you go. Cool, so we've now got a buffer of audio that's filling up with my voice all the time in kind of that amount of space. We have just for now some ugly little Max toggle buttons that allow us to turn off the recording and looping, but we can fancy them up with some nice Max for Live user interface objects later on. Or why not just do it now a little bit? Screw it, why not? Boom. Yeah, so Max for Live does have a load of user interface objects that let you create graphical user interfaces that totally mirror Ableton's user interface and look nicer and fit with Max a bit more. Is this even sending out a 1 and 0? I hope it is. It should be. Screw it, it seems to be working. Cool. So, next stage, we want to play back grains and make cool, granular, giant clouds of stuff. Think about it, James. Use your brain. So, let's just make a single grain. Part of the kind of grain vibe is having these giant clouds of grains. And so you might be wanting to play 20, 40, 100 grains at the same time to make these giant big texture clouds. For now, if we just build one example of that, we can later chuck it into a poly or kind of duplicate it multiple times, and we should end up with loads of big, thick, lovely grain textures. But for now, this will do. Is the music still playing? Last tune. Quick diversion. Probably just putting ambient stuff on, or relatively ambient, but if anyone else has any random suggestions I might have in my library, I may take them. Cool, so playback engine. This indeed has the same record buffer, so that's what we'd play back. It's only mono, but we're going to do some fun panning stuff with it. So let's... Oh, we probably want to randomize the volume as well. So just to get this nearer to the output, let's say once we come out of play, we're going to want to be able to change the volume. So you're going to do that by multiplying the signal. So yeah, I'm sure if some of you are familiar with Max, this all sounds pretty basic, but if you're not, all audio faders, volume faders and stuff like that, basically all you're doing is... oh, wait a minute, does play do that? Anyway, basically all volume faders and stuff like that, they're just multiplications. So we've got a meter object here. If I did something like grabbed a multiplication object and put another meter there, and then multiplied this audio signal by 0.5, it's going to kind of half it, although this is a logarithmic scale fader or whatever, so it's not going to be quite so visible. But yeah, basically if you're changing volume in audio workstations, you're effectively just multiplying the number. So multiplying by 1 keeps it exactly the same, multiplying by 0 totally turns it off, 2 doubles it, and all of that kind of obvious stuff. So we're going to have a multiplication object, because I'm probably going to want to randomize the volume of the grains. So part of the grain is playing like tons of grains at the same time, but not all with exactly the same settings, otherwise it sounds really boring. You generally want to change a little bit to each grain, maybe mess with the panning, the start position, the length of the grains, and all of that kind of stuff to make it a bit more interesting. So we're going to have some kind of volume control at some point, so that's kind of there for now, just doing nothing, just passing the audio through. And then we're going to want to turn it into a stereo kind of thing at some point. So yeah, randomized panning is another typical thing you find on granular devices. So here we're just sending it to another 2 outputs. And in here we can kind of send some panning information at some point in the future to pan it differently. At the minute we're just passing it through, again, full volume each side. But later on we'll kind of have a mess with that. And playback, using play. Did I even use play the last time I built this, or did I use another device? I cannot remember. But for now let's stick with play. So you can drive play with really accurately with audio rate signals and fancy stuff like that. For now, I think we're just going to spam it with the message play. So yeah, play object, you can literally just point at a buffer. So we've pointed it at this record buffer, which is just recording my voice. And then I can just spam it messages, like start and stop. And it should basically just start playing. Pretty much as soon as I'm thinking about this, I'm sure I used a different object that worked a bit better to do this. Screw it. We'll do this for now and see how badly it goes wrong, and then I might change it in a bit. So, let's imagine... I'm just thinking about this a bit further, and I'm sure... Did I even use a wave object last time? Maybe I did. Maybe I didn't. Okay, screw it. Let's go with play for now. So, if I do something like literally just... Let's get a meter out here as well. It should be as simple as... something like that. stop the music for 1 sec. Is this going to make audio playback a bit delayed? No, it's not going to work. That's really handy. It's not cool. Work. That's really handy. Cool. Oh, I think it's doing something. Not going to work. That's really handy. Cool. Yeah, there you go. So you literally just send a toggle on and off, and you can toggle playback, which will start from the start of the sample, and it will play through all the way to the end. We can send it extra messages where we want it to start. So later on, we're probably going to actually want it to start at different positions in the sample. So we might want to mess around with the sample start position to get more kind of fun stuff. So I think we're going to do some of that in a bit. With granular stuff, you generally don't have a loop on the recording. You just want to play it as kind of a one shot from the start to the end. Aha! I just thought about something. Last time I did do this, I definitely just didn't send it messages. I think I used the line object. So I did lie object earlier about just sending it word messages to trigger it. We're going to do a tiny bit of slightly fancier stuff, triggering the play object with an audio signal, and that should actually make it a bit easier later down the line. Okay, so if you have this really simple trio of objects where we've got record buffer recording and a playback buffer playing it back, it's not going to work. It's not going to work. It's not going to. It's not. That's basically nice and simple. We've got audio stored. We can record some more audio. Yeah. More audio. More audio. More audio. Nice and simple. What we can do to do it a little bit fancier though is we can use the line tilde object. So you can also trigger a play object to play rather than just sending it the message play or the message stop, pause or resume. Send it the message loop to loop it. You can do some kind of fancier stuff and decide what bit of the sample you're playing back by sending it audio rate signals. So the play object can take a audio signal. So this sample is 0 milliseconds to 5,000 milliseconds long, so it's 5 seconds long. And we can basically send it a message or an audio signal between 0 and 5,000 to play that bit of the sample. So if I send the sample 0, it's going to play here. If I send an audio signal 2,500, it'll play here. Audio signal 5,000, it'll play at the end. So what I might do quickly is just record a bit of less shit my voice audio. Dun dun dun. Right, that should give us something a bit more interesting than my voice in the buffer. So what happens if I get a sine wave, and I happen to know, so yeah, cycle object in Max makes a sine wave. Whee, there we go, that's a little oscilloscope. This is a sine wave running at 0.5 hertz. So 2 times? No, once every 2 seconds it'll complete its cycle. And like in most standard audio stuff, the audio world generally goes between -1 and 1. So this oscilloscope, you've effectively got +1 at the top. We've got -1 at the bottom, and in the middle is your 0 crossing line, if that makes sense. So that's kind of good for standard audio stuff, because yeah, you want your audio signals to be going between 0 up to the +1, back down to -1. Play, we know we want to go from 0 to the end of the sample. So I'm going to chuck a scale object and scale -1 to 1 to 0 to 5,000. And that should make this sine wave do a different kind of thing. And I'm quickly going to chuck a volume, effectively a little volume thing here, so this doesn't fuck about. For now, it'll be normal. So if I plug this in here, it's probably going to do something really weird. Or it'll do nothing, which is also really handy. Aha, wrong output. Yeah, so scaling from -1 to 1 to 0 to 5,000. Yeah, so that's kind of weird. So what it's basically doing is it's playing back the audio buffer in a sine wave, kind of like this, playing forward, then reversed, then forward, then reversed. Let's make this really, really slow. Yeah, and the speed at which you play it will obviously affect the pitch of the resulting audio, because like a vinyl deck, the faster you play it, the faster you play it, the higher in pitch it will be, the slower you play it, the slower it will be. Ned, yes, you could use cosine, probably. I just always use cycle for sine wave stuff. I was just messing around. Obviously, yeah, if you wanted to do this more sensibly, you could use various other waveforms. Like you'd probably actually, for this job, be using, like, if you wanted it to play in loops, you'd be using a phaser, because a phaser is basically a ramp waveform for people that don't know. Rather than doing sine wave stuff, a phaser does a nice ramp upwards. So if we didn't want it to do all this weird stuff, going backwards and forwards and doing these weird reversals, we could just scale 0 to 1 to 0 to 5,000 and trigger it with a phaser instead. And that could just not do anything, which is really fun when you're programming max things, when it just doesn't do anything. Why would you not be doing anything? Oh, I plugged a scale into a scale. That was a pretty stupid idea. Cool, so that's just to illustrate this kind of concept where what we're doing is we're playing back the audio sample now, using audio rather than just start and stop messages, and that gains us slight advantages where, so this scale object is scaling this phaser, which outputs 0 to 1, it's scaling it to 0 to 5,000, which is the length of the sample. But if we wanted to just play a small portion of the sample, we could set it to start at 0 still, but we could make it play just half of the sample. So if it went from 0 to 2500 instead, it's now just going to play this little first half of the sample, or we could go really small. I think the slight issue is whenever I change the length, it's also scaling the speed at which it plays. Have I just got a really terrible bit of the buffer that's not going to work? Yeah, anyway, we can trigger samples, set the start and end point of the loop kind of thing. If you use a phaser, so just like a continually running waveform, it basically will just run all the time. Loop back. So you can do kind of looping stuff using phasers and triggering them at the right time, turning the looping on and off and stuff like that. We don't want to do that. We're doing granular synthesis. We just want to start a grain and we want it to play from the start position we define. We want it to play for the length of time we define, and then we want it to end. So for now we're going to disconnect that. And I really have a feeling I actually used a wave object or something else originally to do this, because a wave probably goes from 0 to 1 and that's a lot easier to mess with. We'll stick with play for now, but I think I'm going to swap it out for a wave in a little bit. So, next job. Instead of triggering with a phaser, which will do kind of continually running ramp, we're going to use a line object. And instead, a line object will just do a single kind of one shot. So if I send it the message 0, so start at 0, and then I want you to go to 5,000, and I want you to get to 5,000 in 5,000 milliseconds. So that's going to go from, it's going to start at 0, it's going to try and go to the value 5,000 over 5 seconds. Well, there's no point running that into that oscilloscope, because that oscilloscope is going from 0 to 1, so that is going to look stupid as hell. So instead, I'll scale 0 to 5,000 to -1 to 1. And that might give you an idea of what it's doing. Boom. Cool. So whenever we trigger a thing into line, it will run, and yeah, see that one just run basically from 0 up to 5,000 in 5,000 seconds. So that would effectively mean it's going to play back at normal speed. So if I run that into here, we should get the sample played back in full normal speed. Cool. Yeah, job done. If we decided to play from 0 to 5,000 in half the time of the sample, that's effectively double. Terrible maths. So that's how you can mess with the pitch and get samples playing back at different speeds. Obviously you can do low stuff as well. Pretty simply. And if you want to change where you are starting in the sample and where you're ending, instead we're just going to change. So basically this line is defining many of the fun things you want to do with granular synthesis. You want to define where you're starting in the sample. You want to define where the sample is going to end, or the sample duration. And then you want to define the playback speed or the pitch. So you could quite easily turn this into a kind of semitone quantized pitch thing. Hopefully. So we're getting to the point where we have something that vaguely does a job. We've got volume here. We've got this thing which is going to play back a sample at a start position, an end position, and a speed, aka pitch. And then we've kind of got these panning things that we haven't really done anything else with yet. Let's quickly turn that into some actual panning. So generally when you pan things, obviously we've got a monophonic source here. This is panning, not balancing. So we've got a monophonic source. We want to turn it into 2 channels of a left and right. And we want to be able to control how much left and right is going. So if we chuck another floating point and we say this is our volume, this is going to be our panning. Ooh. Screw you. Yeet. Cool. So we want to turn this one number in to multiply these 2 boxes. So if we were going to pan all the way to the left, we want this number to be 1 and this number to be 0. If we want to pan all the way to the right, this one on the right probably needs to be 1, this one on the left needs to be 0. If you wanted them to be in the middle, you'd kind of think of this one being 0.5 and this one being 0.5, that kind of thing. That would be a simple kind of panning idea. So what you'd probably do is you'd take this number here and you'd turn it into 2 numbers. You can just split it into 2 or do something like that. One of them we'd send to one side normally, and the other we would invert. And my terrible maths brain might not remember how to do that properly. If I have, it will be a miracle. Is it this? Is it something like this? People who are good at maths, can you remember how to invert a number quickly. Whee! It was the exclamation mark minus thing. So effectively, out of the left-hand side, we have the number going from 0. Ooh. These need to be floating point, not integers. This isn't a beginner's max course, so I won't bother explaining that too much. But yeah, decimal point numbers instead. Yay. Cool. So when this goes up to 1, this number over here is 0. This one is 1. When we go back the other way... Cool. And if we were going to be right in the middle, you'd be like 0.5. So you could kind of set something up like this for panning. So if we did this way faster, so we don't need to listen to it for that long, let's half the playback time and make it play back at double the speed. And now let's try and pan it. That's going to be all the way right, I think. Oh, I took my right earphone off so I can hear that. Wait, that's all the way right. And that way should be all the way left. And somewhere in the middle should be there. Cool. So you might want to mess with that number a bit more, because at the minute we're sending 1 to get 0 right. That kind of doesn't make sense. You'd probably want to invert these the other way. So 0 goes left, 1 goes right. That kind of makes more logical sense. So that's how you pan a really basic, how you program a really basic kind of panning thing. Some of you people, clever people who know about panning and numbers and stuff, might know that you actually don't do panning like that at all, because audio works logarithmically. So we hear noises on a logarithmic scale. I think that's right. Not exponential, I think. Not, hopefully. I'm not totally wrong. So we notice differences, small differences in loud sounds a lot more. Actually, it's the other way around. God, I should learn what I'm talking about before I do these streams sometimes. Anyway, the point is, if you do 0.5 on these numbers, these are both going to sound too quiet. So as you pan between them, you'd kind of hear this drop in volume. That kind of wouldn't be... Oh, no, that is too slow. Can I just shove this in here? Cool. And the answer is... Oh, yes. Cool. 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 Basically, when you're making panning, you do not want to just do straight linear multiplication like that, because when they're in the middle, they don't sound loud enough. They both sound like you've made them quiet. So what you want to make is an equal power panning thing. Like on DJ mixers, you have crossfaders, and when you're crossfading between the two channels, you kind of make equal power crossfader settings and stuff like that rather than linear. Or, you know, if you ever used a DJ mixer, you have different kind of settings and stuff. Most panning, you want to have a equal power panning law. So luckily, is there a abstraction that already does this? We'll have a quick look. So in Max for Live, there's an abstraction the nice guys at Ableton or Max already made, because they use it in some of their plugins. But basically, rather than just multiplying these linearly from 0 to 1, we want to make a constant power panning thing. And to do that, we use multiplication objects like we were, but rather than a linear line going from 0 to 1, we use a logarithmic, or whatever, a curved line, basically. And that actually allows us to have constant power panning, where in the middle it doesn't sound horribly quiet. Those are lovely errors there. So it looks like we're going to grab some cycle objects, which, as we used a little bit earlier, allowed us to make like a sine wave. And if we chuck that in a scope, we should see a line somewhere maybe, and we should be able to control the phase of that sine wave. Ooh, to like move through its cycle. So if you ran like a phaser into this, we should just see it cycling in its nice sine wavy way. And it looks like looking at this patch over here, I'm kind of picking it apart as we go because I can never remember how this works properly. We want to multiply one of these on one side by a certain amount of a sine wave, and the other one, so I think this one we want to kind of go like that, and the other one we want to go like that. So rather than just going straight linearly from 0 to 1, we want to kind of go in a nice little curve, and then a nice little curve off again. And to do that, we actually control the phase of a sine wave, and if I look here, it looks like it's going from 0 to 0.25. So if I go from 0 to, that's way too big, to 0.25, it looks like it's kind of doing that kind of motion. Okay, this could make sense. So we're going to replace this bit of lazy, crappy linear pan algorithm and do a nice equal power one. We're going to scale, well, we kind of want it to go, nice panning things normally go from -1, 0 in the middle and then 1 at the end, don't they? So let's say we scale -1 to 1, and copying the other patch over there, we're going to go like that. And, oh, why did I just do that? Oh, no, I do not want you either. Open up our panning thing again. Cool. So while one side of this cycle is gonna go one direction, so it'll go from -1. Ooh. So this is gonna go from -1. Ooh, over there. Okay. So as we pan into the 0 point, yeah, rather than being at, so this is 0 here, this is 1 here. If we're multiplying linearly, when we go from 0 to 1, it obviously just goes. So at 0.5, you'd be here. At the minute, we're halfway through the pan, and we're actually a little bit higher. That's kind of 0.707. So basically, you get this equal panning pan law thing. And I just did it again. I promise we'll stop talking about panning in a bit, but just going to try and finish off this panning part of it quickly. So we've got one side going that way, and the other side we want to go into the phase of another sine wave, but on this one we're going to, it looks like, plus 0.75. So one of the important things to remember about Max is if you have no idea what you're doing and you can't remember what you're doing, open up a patch someone else made and copy all the code from it, and then you should get a working pan algorithm. So when we're at 0, which is the middle point, so right down the center, both of these channels, rather than sitting at 0.5, they're actually sitting at, I bet that is 0.707 if I could type. Yeet. Cool. So yeah, when you're at 0, ooh, messed that up. We have a nice How did I just totally break this object? We'll find out. So when we're at 0, it's sitting there. As we pan to the left, we should see is that correct? That must be correct. What was I expecting to see? Was I expecting it to do something different? 0, we should be in the middle. 1, -1. Does this make sense? I think I was expecting them to be a different way, but they are not. Why are they not a different way? 0.75 into the phase of the cycle. That's basically that whole patch copied pretty much exactly as I can see it. I'm not sure why it's not doing the exact thing I thought it'd be doing in the scope. Something has gone wrong. 0.75. Let's just try recreating these objects. I'm close to giving up on panning and just leaving it as it is for now, because this is probably the most boring part of the stream, building equal power panning laws. And we should probably get back to actually making some grains rather than staring at equal power panning laws. But the general concept was you use a cycle object to make things have a nice curve. So when you change the volume, they change in a nice way, rather than doing linearly and losing volume when you're in the middle. We use sine waves and control the phase of them. But for some reason, this isn't quite working. I hate it when things do this, but I'm sure I've just made some weird mistake. Oh, I need to reinstantiate the objects. If this doesn't work, I'm definitely giving up on panning for now. Plus tilde 0.75, and that wants to control the phase. That wants to control that. 0, yes. -1, yes. Yeah, screw it, I'm giving up for now. What the hell? It's kind of in the middle. For now, it will do. And I will figure out why that is broken in a bit. If anyone else can see why that is broken, let me know. For now, I am giving up on equal power panning, but it will do for now. So, back to actually hopefully making granular synthesis and grains and making fun sounds, not just staring at panning laws for ages. So this is our kind of balked and not working, but we'll fix it later, panning thing down here. Here is our volume control effectively. This is our play object, which is going to play back a sample. This is our record bit and our buffer. So what we want to be able to do next is probably have a nice way of being able to control the start of the sample, the end of the sample, and we want to be able to control the playback pitch or speed in a slightly more usable way. Maybe we want to actually quantize it to semitones so we can actually generate useful pitches and stuff. So I'm going to turn some music back on briefly because we're going to be in programming land again for a little bit. Right, so we're using a line object to play through the sample, and we're going from 0 start point to 2500 halfway through, and we're doing that at half that amount of time. So this would play the sample back from 0 to halfway through, and it would play at half the speed. So what we want to do to control this, sometimes I find it's good to think about the controls you're going to want to have at the end. So let's just quickly make some live user interface objects, think about what the UI is going to be, and then try and match them up to the programming underneath. So we're going to want to have a start dial, and this is going to be let's find a way to name it. Start, and we are going to make it go. We could set it to kind of hard go from 0 to 5,000 because we know this buffer we're recording into is 0 to 5,000, but we might want to mess with that. We might want to change it. We might load in other samples. We might change the length of the buffer because 5 seconds is too long or too short. So instead, I'm going to set this to be 0 to 1. No, actually, I'm going to set this to be 0 to 100, and I'm going to make this a percentage. And the initial is 0. So the initial start point is going to be the start at 0, and as we turn up percentage, so effectively we're putting the start point from 0 to 100 of this current sample length, because this sample length could be variable. We could load in a different sample or record a different length buffer. So that's kind of one main control we're going to want. We're going to want a, rather than having an end point, I normally find it's good to have a duration. And again, we're probably going to want that to be a relative control, because we're going to want it to be the relative duration of this current sample. Because if we loaded in a 5-second sample, we might want to set the duration between 0 and 5,000. But again, if we've loaded in a specific sample or whatever, we might want this to, we always basically want 50% to be play half of the sample, whatever length it is. So we're going to call this duration, and we're going to actually probably set the initial to be 100. So by default, we've got our user interface controls set to play from the start to play the full length of the sample, and I think we probably also want to have some kind of pitch control. So to do that, I'm going to make another dial and call it pitch. Oh, and let's say, I'm going to have to do some maths to work this out at some point. Let's say we wanted it to go from 48 semitones down to 48 semitones up. Is that 4 octaves, I think? Again, terrible at maths. And let's make that one of those pretty things with the triangle. Yeah, so it's more like a panning dial. You can do that with it instead. We're going to want to have a global panning dial as well to control the panning of all the grains, although we'll probably randomize them around that. So for now, we'll make one more user interface object called pan. And the panning just goes from -1 to 1 instead. And volume, we'll probably put one of these nice, is it live.gain controls at the end. Volume. And we'll do a kind of volume randomization thing at some other point, but that'll just be our nice kind of master volume control. So we're gonna have a mess around with this line object and try and make it so we can control the start point, end point, and speed at which we're playing. To do that, and to do that with our relative percentage kind of base controls, rather than our hard-coded 0 to 5,000 or whatever the length of this buffer is, we're going to need to know the sample length. So at the minute we happen to know it's 5,000, because that's what he set it to, and we could edit that somewhere, but if I remember, there's a magic object somewhere in Max that lets you get information about a file. Is it info? It is info tilde. Great, I actually remembered that one. So another one of these objects that inherits its name from the others is this info object, and info gives you information about a sample that's loaded into a buffer. So we've got the record, named it the same record object, and one of these outputs, what we're going to get, sample rate, all this kind of stuff. Let's not fuss around with sample rate for now. Buffer duration, or length in milliseconds, and that is the third from the right. Bam! Cool. So when we bang this, we get the length of the sample. So if we were doing something where we were loading in different samples, which you can do with like a drop file object, so if we put this in the user interface, we could drag files onto here and fill this buffer with things we'd loaded rather than recorded, and that we could then bang this to get the information on how long the sample is, so we know what the end point and the start points are. I think what we're going to want to do is store this so we can use it at other places in our code. In Max you have a value object, and the value object lets you store a number and then access it at multiple other points in your patch. So I'm going to create a value object, and again I want this, so a value object is again something you can recall or call that information at numerous other places in a device without having to attach a patch cord to it. So I'm going to use our little hyphen kind of thing, so it generates a random number. Sample size, that'll do, that's a good enough name. Oh, and I colour it something. I love colour coding stuff, it really helps in Max to quickly scan and see what's going on. Anyways, we've got a value object called sample size, and in it has what the sample size currently is. Bam, bam, bam. Or it doesn't, because I didn't connect that correctly. Sweet. So we can now use this value object at other points of our code, in other bits of our programming, without having to use this info object again or stuff like that. So let's make this start control actually do something useful. So this goes from 0 to 100. I am going to multiply that down into the nice, familiar for programming range of 0 to 1. Which is something I always tend to do with percentage controls. And if you remember looking at this line object, this first number here, the 0 object, the 0 number, is the number that sets the start point. So we basically want to be changing that number. And as we scroll from 0 to 1, I want that to be converted into the current length of the sample. So with the current length of the sample being 5,000, this should be 0. We should go up to 2,500, up to 5,000 at the top. And if we change that to a different length, we want it to mirror that proper length. So one thing we can do quickly is add in a multiply object and make a trigger object. So every time something comes in the top of this trigger object, we're going to send through the floating point value of what this current dial is, but we're also going to bang what our current sample size is, and we're going to multiply those two numbers together. So we're multiplying at the very low end 0 by the sample size, which is currently 5,000, so we get nothing. As I scroll up to about halfway, 50%, yep, 2,500 all the way up to 5,000. Cool, so our start control will now control where we're going to start in 0 to 5,000, which is the correct sample length. And I think we then want to use our duration to do something useful as well. Again, I'm going to multiply it down into a nice usable 0 to 1 range. And I think we need to do pretty much exactly the same thing again, actually, don't we? Wherever the duration is, we just want it to mirror and tell us what that currently is in actual real sample milliseconds time. And for now, let's not worry too much about pitch. Instead, let's just always have the pitch part of this be playing back at normal speed for now. So to do that, we also need to get pitch dial. Don't need to multiply it into that range, but let's just imagine you always want to send through the actual sample size. We'll mess with pitch later. But basically, so if we send through the actual sample size, it's going to play at its proper length, at the proper speed, sorry. Sample size here will set the start point, duration will set the length. And brain. So we need to format a message which starts with 0, has this second number, the duration, and then also has the speed or the pitch on the end. And whenever we the one other thing to think about is whenever we change one of these dials, we don't want it to immediately trigger the sample to like play again. So if I set these numbers up to trigger the message, and whenever I just change this, suddenly the sample would start playing again. You want to be able to mess with the sample start and the duration and the pitch, and it's only when you actually effectively like click the note on your keyboard or we trigger it to play, that's when we actually want it to play. So to actually decide when we're going to play these samples, quickly I'm going to make a metronome object. So the metronome object just sends out a bang message in Max, which is basically just like a do something, do it now object. And if I set this to trigger every 1 second by just typing 1000 milliseconds to the right hand answer, and if I turn it on, yeah, so that's now just banging every second basically. So what we could do is we could have this, if we just set these back to absolute basics, we plug this in here, we basically got a playback basic playback method where we can turn, if we want the effect to run, turn it off and it'll play the length of the sample, then stop. And as we turn it on, it's going to play every second, and we can make it play increasing speeds. Back to playing so quickly, there's silence at the start of the sample, so you can't even hear it. But yeah, so that's how we're actually going to trigger our samples to play grains, or you could trigger it by pressing a note on the keyboard and stuff like that. Back to music. Cool. So, next step, we want to form this message that's going to trigger these grains to play. How are we going to do that? Come on, brain. So whenever we receive a bang from here, we first want to find out what this number here is. So let's grab this over here. And what we're going to do is instead, let's put the logic on this side, it'll be nicer. So we're getting a floating point number from this dial, this control, and it's going to be from 0 to 1. So we're going to store that number here using this float object. So the float object basically just stores a number, so you run it into its cold inlet in Max terminology. Whenever we change this dial, it's not actually outputting the number, it's just storing it. But if we ever run a bang into the hot inlet, it's going to output whatever this dial currently is. So in that way we can keep track of what this user interface object is, and it's just when we actually trigger a note to play, we're going to get what the current value is. So if I store that play number and chuck that here, so the message the line wants is going to need to start with 0, which is our play position. So that's here. We're going to want another one of these jobbies for the duration. Get that into there. And for now, we're not going to mess around with pitch too much. We're just going to make it always play back at normal speed, and we'll deal with programming pitch later. So you imagine this is our note triggerer. So when we press a note on a keyboard, or when we just want it to, say we want to just trigger a grain cloud and it's just triggering regularly grains every quarter of a second or something, we're just going to turn this metro on to trigger it. And this is effectively our play message. This is sending bang, do something. So the first thing we want it to do is we want it to send the start position to the line object. Because the first thing it does is receive a 0. You might not see by this message formatting, but it's a weird trick in Macs where if you add commas into a message box, it sends them separately. So if I actually sent this message and triggered it to the Mac's console over here, it would send 0 on its own, and then 5000, 5000 as a list. So the line object, you send it a number first on its own, and that says play from this start position. And you then want to add together into a list the duration and the length, or the kind of pitch effectively. So we're actually going to be sending the line object 2 messages. The first is the start position on its own, and then a list of where to play to, or the duration, and the pitch. And that should... I'll add another bang here. Again, this is just messy logic, no real pitch logic there for now, but just imagine we're going to do some cool pitch stuff here for now, using pitch quantizing and octaves and whatever to multiply that number. So I guess basically if we had the sample length and you wanted to play it twice the speed, you'd kind of multiply that number by 2. But then you also kind of need to take into account the duration as well. So there'll be some kind of maths that I've forgotten, but probably won't be too tricky to work out later in there. So if you imagine this is our play button here, first thing we want you to do, we want you to send a bang and trigger the sample to play. We then want you to send the sample size into the right hand side of this join object, and then we want you to send the duration into the join object. And now whenever I press this, it should do absolutely nothing yet again. Yay, max programming. Brain. What has gone wrong? So this number, whenever we bang it, should send out 0. Yeah, looks good to me. And the second list it sends, it should hopefully send out 5000 and 5000. Oh, it just magically works when I add a message box there. Thank you, Max. So now, effectively, what we've got is a play button where we can click play. It's going to trigger the sample size, and so now we could actually change the start and the duration, for example. We're not actually changing this correctly, so this might sound weird. Yeah, because I've changed the start point and messed with the duration and therefore changed the length of the sample. It's going to play the different pitches like a vinyl player kind of thing. So we're going to need to work out the maths for that in a bit. But for now, we can actually change the start point of where it's playing from. Yeah. And if we wanted to make it a bit more, well, eventually grainy, we're going to be triggering this at a regular interval to make kind of grain clouds. Yeah, so that's kind of a rough beginning of something granular, although I'm definitely going to need to have a think about maths and try and get this pitch working in a less useless way. Back to music for 1 sec while we think about maths. And have a cup of tea as well, actually.
Ooh.
So the choices are think through maths, or look what I've already programmed a couple of months ago that I forgot how it worked. If we just look at the one I've already programmed, we'll have the answer immediately. If I try and work it out with my probably not caffeinated enough brain, it might be a bit longer, but maybe that'll... I'm not sure which one is more interesting to people. Me trying to actually figure stuff out and looking at the process of how the hell you figure stuff out, or is it more interesting if I just plug it in from the one I've already made and it just works instantly and we know how it works? For now, let's try and do maths, or if anyone has an opinion on that, just write it like in the comments. But for now, maybe we'll try and take the hard route and actually do maths, which sounds horrible because I hate maths, but for some reason I sometimes like programming stuff. Right, numbers. When we are playing from the start, which is 0, to the end, that is going to correctly give us 0 to 5,000 in 5,000 seconds. If I say change the duration, so this is just going to play halfway through the sample. Oops, sorry, that's 50. Come on, brain. Then that effectively is now still stuck at 5,000. Quick hack is what happens if you actually just make the duration be the second number as well. Does that do it? I mean, effectively that would do it. That's definitely not what you want to actually be happening in the end, but... So the pitch is going to need to take into account the duration at the same time. But the start point in effect shouldn't matter. Is that right? Is my brain thinking correctly? Ooh. Oh, no, it's not thinking correctly. Because effectively, if we change the start point to say 50, this is going to send out 2,500. That's 5,000. That's 5,000. Oh, so we're probably going to need to change the logic of this a little bit, because effectively what's happening at the minute is if I change the start position to really near the end, the line object is only going to play yeah, it's kind of going to play a really tiny short sample, so it's kind of ignoring this duration thing. What I think we'd actually want it to happen is that we want it to play for a set duration. So if we're playing for this duration, we want it to be a true reflection of what that duration is. So if we set this to 5,000, it should play 5,000 seconds of audio, regardless of where we set the start position. So if we set it to start halfway through, but the duration to be full, it should play from halfway through the sample, play all the way to the end, then probably loop back to the start again and play some more. How would you do that? I think instead we'd need to use a modulo object in here. I'm just trying to think how this is going to work. So a modulo object basically allows you to fold or wrap numbers so they kind of wrap back round. So if we wanted to start playing halfway through, it would start at 2500, play all the way to here, and then it would kind of jump back to the start again and play back to that middle point, because it's going to play for the full duration of the sample. It's going to start halfway through, it's going to play all the way to the end, let's jump back and then play back to that middle point again. So to do that, I think we would need to use the modulo at some point. So we're going to need to control the number wrapping at some point. And so that would mean we need to separate this kind of duration control. You know what? I don't think I've had enough caffeine to properly be thinking through this granular engine for some reason. Even though I worked it out last time. So for now, I'm going to quickly open up one I messed around with earlier in typical Blue Peter fashion. And hopefully we'll hack a tiny part of the code without stealing too much of it, and we'll get something useful. Here is a bit of a device I made earlier that did loads of this stuff, and hopefully it's going to end up looking a bit more like this eventually. Let's look at the secrets. Oh, I did it all in signals later on. Duration is here instead, and it does set how long it plays for, but it doesn't actually control the start position. Ooh, well, there's some pitchy stuff with power of exponential things. I'll probably come back and copy that later as well, because damn, having to remember that. Yeah, modulo, making sure it stays within limits. Start position here. Okay, so I think probably the last time I programmed this, I realized all of the issues my brain is now running into trying to program this. And I did this in a slightly different way, and I think we're going to copy that because it seems to make more sense. I was using the play object though, and I did have this, and God knows why this bit of panning, equal panning law code looks exactly the same here and worked, but the one we put in somehow just isn't working. Who knows why? Yeah. Okay, so we're going to change up what we've been doing based on the code I did earlier that actually worked properly, and we won't need to spend quite as long thinking about. Right, so it looks like what I'd done in the other patch is, instead of trying to mess too much with the numbers going into the line object to generate the start point and the end point and the pitch of the sample, I was actually doing some of that work in another place in the patch. Thank you, macOS. Do something useful. I was actually controlling the audio signal that was coming out of the line object, and I was messing with that to control the pitch, and yeah, I was also controlling the start position using that into a modulo. That kind of makes sense. So instead of faffing about controlling the message here, we're going to actually change the audio signal to do the same job. So I'm going to make some space. And I think we were always triggering from 0. So effectively we're going to get rid of this start code. Start's actually going to do something somewhere else. So whenever you trigger a sample, you are actually just going to start this line from 0. So this line is always going to generate from 0, for now at least. And the duration is going to set the duration though. So what we should get there still is the same old. Trigger it, it plays from start to end in the normal length. What we're going to do down here though is, so this play object, like I said a while ago, you send it an audio signal from 0 to the length of the sample, which is, so this, using this maths here, it's triggering a message. This audio signal is effectively going from 0 to 5,000 in 5 seconds. What we can do to basically add this kind of looping functionality. So what we were trying to get to was a point where if we start the sample halfway through, rather than the sample now starting halfway through the buffer, getting to the end and then just stopping dead, so effectively only playing for half the duration, we want it to, if we did have the start position halfway through, we want it to start halfway through, play all the way to the end, then loop back and play to that middle point. So the duration effectively is a true, accurate representation of what's going on, and the start position will be accurate as well. And with any luck we can mess around with the pitch and add that kind of fun stuff in. So to do that, at the minute, the output of the line, going from 0 to 5,000, is running direct into play. We're going to add a modulo object in there. If I try and make an example of that here quickly, in fact I'll just do that with normal max objects rather than audio objects. So what we should see is it allows you to kind of wrap numbers, is the way I think about it. I think there's something to do with divisors and division and showing the remainder of the division, but in my brain I normally think of it as wrapping. So if we start at 0, I've set this modulo to 10, so if we start at 0, it's going to go just from 0 to 10, but as soon as we cross or hit 10, it actually loops back to 0 and goes up to 10. So you kind of limit the number. No matter what we send in here, it'll never go higher than 10, but it'll kind of always loop back to be at that position. So if we went to 11, it'd be 1, 15 it'd be 5, 105 would still be 5. That kind of thing, if it makes sense. So we're going to chuck a modulo object in between here. So that's going to wrap the numbers. And if we grab a sample size value here and we make that control the length of where the modulo is wrapping, boom. So effectively this modulo is stopping this line from ever going above the sample size. So it will never play, it will never try and play audio that doesn't exist on the other side of the sample here. If the line ever tries to go further and go outside of where the sample exists, it'll actually loop back to the beginning and start playing the beginning portion of the sample. So next, that's allowed us to make sure we never play beyond the sample length. The next thing is we're now going to chuck something that controls the start position. We're going to chuck it in here before the modulo. So we want the start position to push the start point between 0 and 5000, but we're going to make sure this line always wraps back. So to do that, we're going to want to use a addition object, and I think it might even work kind of just like that. Maybe, possibly, could do. Let's try and have a look. So if we set the start position to 0, set up some number boxes here so we can see what's going on. So this is going to show us the raw line, which always goes from 0 to the duration we set. And currently, because of a little bit of an ugly hack there, it's always going to play at the time that duration should be. So if I set this to 50, it should be the half the sample size, which is 2500 in 2500. Yeah. And the start position is set to 0. So when I trigger this, the line object goes from the start of the sample to halfway through the sample. And that's kind of it. If you wanted to make this prettier, we could start doing a nice little bit of kind of user interfacey stuff. User interface break. Quick break from programming to make a little bit of a playhead. No, I do not want this to be a weird gradient thing. Just make it red. Red. There we go. Off color. Opacity go away. Background go away. Chuck that on top of the sample, roughly. Make the sample a good size. This is a slider object, and it goes, let's say it goes from 0 to 1. If I send it a 0, what happens? Stays there. Whoop. Yeah, goes all the way up to 1 to the top. Scrolls back down, and let's make that just be a single indicator. Whee! Playhead. So this is sending a number. This is 0 to 1. Yeah, that makes sense. So we're just going to change this audio signal. You can use a snapshot. So a snapshot converts an audio signal into a standard max control data, kind of grey signal. Again, maybe I'll do an intro to Max thing one day explaining these kind of things. But just like in IRL audio world, you can't plug a jack cable into like a MIDI or a USB cable. These are kind of like jack cables or XLR cables. These are kind of like MIDI cables or USB cables, and you can't just plug one of those into the other without kind of something going on in between, basically. Is how you can think about it. So with any luck, if I play this now... Oh no, I forgot to scale it. So yeah, snapshot object is turning it into data, but this fader just goes from 0 to 1. So, wait, scale. God damn it, I need to know the sample size for this, won't I? That's fine. Let's do proper maths brain stuff. Yeah, scaling 0 to 1. Oh, that's basically going to do it actually, isn't it? Maybe? So that's going to be from 0 to... Ooh, other way. Let's think about this slightly differently. We're going to use a scale object because I have to think about maths less if I use one of those. This number is going to go from 0 to whatever the sample size is, which is currently 5000. But we're going to chuck that in there so it changes. And we want it to end up being 0 to 1. Trigger, send the number through, bang this, set play position of nice little, not UI tilde, just normal. So yeah, another thing in Max I haven't mentioned, because this isn't so Maxy, Max intro-y, is yeah, objects with a tilde work with audio. Objects that just do data do not have a tilde. Do something. Yay! We now have a little UI that kind of like shows stuff. So when we play our sample from 0 to halfway through, so start position of the sample is 0, yay! Duration is halfway through, and it's going to play at the correct pitch because of this ugly little hack, which is just making it play the right thing. Play. Boom. So as we can see with our nice kind of playhead thing, and if I stop the audio we might even hear it. Or not, because I must have messed something else up down here. But the idea being, we're now triggering the sample to play from the start to halfway through. And it should be doing that. Let's just chuck something back in the buffer, just a bit less ugly. Something should be in the buffer now. This is definitely looking at the right buffer. That's definitely playing. Is it not outputting? Ah, because the audio is then running into this other granular device that I had as well. Let's chuck that over there. Great! So now we're triggering it to play every 4 times a second, and we should be able to see it's playing there. If we move the start position to say halfway through, is that going to work properly? No, because this isn't being triggered to update yet. So we want to trigger this as well. Kind of ugly, but that'll do. But duration, you should be playing for the whole sample. Why are you not doing that correctly? Ah, too short. Let's turn that off. So if I set the start position to 0, the duration to halfway through, that does correct. If I set the start to 50, halfway through, duration to halfway through, it should play from halfway through to the end. Yeah, and if I set duration to 100, but start to 50%, it should start in the middle, play all the way to the end, wrap back round like it's looping, and play to the halfway point. If this all worked correctly, we'll find out now. N. N. Why did that not do what I thought it would do? The pleasures of Max. Working out why things aren't working. So, we want to trigger this. This is a start message. It's going to trigger this, which should work out what the sample size is. If we set start to be 50%, halfway through the number is not that, is it? Come on, brain. You've done this very wrong. That's multiplying it, so you're going to get half the value. And we do not want to get half the value. We want to get like the actual number in there. So my brain went wrong doing that bit of maths. Then how would we correct that? Why haven't I had enough tea or coffee to think about numbers and maths properly? I think we are kind of going to want to multiply these numbers somehow. Are we not? If anyone else knows maths, as always, feel free to chime in. When this number is 0.5, we kind of want to be like looking through this sample size and getting 2,500. We don't want to be getting half of it, because that just doesn't make any sense. Let's try and use our handy scale object, because that normally stops me needing to think about maths, and the less we have to think about maths, normally the better. So start is going from 0 to 1, so we're going to scale that number between 0 and whatever the sample size is, which currently is 5,000, but it could be something else. Let's get rid of these. When you get a number here, send through the number to be scaled, but set this to be the endpoint first. So the sample size is now setting this last number, what the number is being scaled to. The first number is coming through here. Oh, scale tilde again. We're not working in audio, we are work in control MIDI land. And now when I change this, ooh, not like that. And let's ugly hack this just to do this for a sec. Boo. Nearly, maybe. Still not quite. Brain. Scale from 0 to 1 to 0 to 5,000. That's definitely what we want to be happening. Why would you not be happening? The length is 5,000. This is definitely 5,000. Why is my brain forgetting how to do maths? 0 to 1. Yes. Is this number 0 to 1? Yes, it is. Better be. God damn it, numbers. Yeah. Oh, and again we run into this nice issue where as soon as I plug a message box in here, the numbers magically start working. Well, that's what I get for using beta testing versions of Macs. They do weird things like this sometimes, and next time I'll remember to install the last version that's actually known to work properly. Now that should be working properly. Let's try plugging that in. So this little bit of maths, well, not maths, using scale to stop us having to think about maths as much as possible, should be allowing us to set the start position. And let's try that thing one more time. We're going to set the start position to be halfway through. So we want to play from halfway through the sample. We want to play for the full duration of the sample. So we want to start halfway through, play all the way to the end, loop back to the start, and play to that midway point. End, and then just... Oh god, it actually finally worked. Yeah. So I'm glad that bit of maths, or non-maths, or patching actually finally did what we wanted. And yeah, just remind me to maybe install the last working version of maths rather than the beta version before streaming. Because unless I was completely mad, I'll watch this back, and for some reason adding a message box made the result change, which is not what you want Macs to be doing. At least not in the stable version. Maybe something in a weird testing version changed. Anyway, we now have a start control that actually accurately controls end and then just position of the sample. We have a duration that, with any luck, actually allows us to play little duration-y things And if we did something like go all the way to the end, and then just, ooh, it's going to allow it to actually wrap all the way around, end to play for the full duration. And we have our little autoplay thing as well. So, effectively, we've just made a kind of playback engine so far. Hopefully, we are quickly going to massage this into being like a bit more granular by adding some randomization, like start randomization and end randomization and pan randomization. And because we're going to do some more programming, I'm going to chuck some audio back on. Who the hell is Pariah Carey? Audio to listen to while we program. Ambient stuff. What's ambient? What have I got recently that's ambient? Screw it. Let's actually listen to the latest Rob Cluth album on Houndstooth while we program. That seems kind of apt, considering his enjoyment of programming music stuff as well. Right, more tea. Quickly, before we add in the randomization and put this into a kind of duplicate this multiple times, because at the minute we've effectively just got one sample engine. And we're just triggering it once. It's just playing through once, one at a time. If we trigger it loads of times, well, we're just triggering it to play really quickly, like a one looper. What we actually want to be doing is we want to be triggering tons of sampling engines. So for Granular, you might want, yeah, like 20, 50 sample players effectively all living in one. And they all play at different times, one after the other. So you can have up to 50 of the same sample playing at the same time to create these really thick, big grain clouds. Yeah. Let's first do pitch. Before we put the things into the poly, let's do pitch. And one other thing we need actually is an envelope, because at the minute it's just starting and ending, and depending where we've set the start and duration, it might start like halfway through a sound that's playing. So if you're familiar with audio, you'll know about like zero crossings and stuff like that, or why you have envelopes. Basically, you want audio to start from 0 and then play the waveform, whatever it is. You don't want to start something playing and it just jumps to playing at a value. Don't know why I'm scraping around a scope. If you imagine there's a scope, let's get some waveforms. Here's a waveform. I think you know how zero crossings work. Do I even need to explain this? No, probably not, but we've gone this far. You want audio to start at a 0 point, somewhere here. If you start a sample playing like here, it's going to create a weird click sound because the audio is suddenly going to jump to this value up here. That's why square waves sound so abrasive and have so much like high harmonics, high frequency content kind of thing, because they're quickly jumping across the 0 crossing point. We want it to start at 0. You can kind of do that in Ableton, but anyway, we're going to do that with our granular sampler thing by adding in an envelope. So we have a play object. It's playing some audio down here, but it might be clicky because it might start at a non-zero crossing point. So what we want to do is we want to add a envelope that makes sure it plays nicely, starts at 0 and goes down and ends at 0 as well. We're not going to add your typical kind of ADSR envelope thing. We're going to add a kind of make an envelope that lasts as long as the sample that's currently playing does. And I don't know, this is just some weird tip I picked up years ago looking at picking apart Max samplers. So what we're going to kind of do for this is we're going to make another buffer of audio. So we're going to store some more audio in RAM. We're going to call it envelope, and it doesn't need to be very long, just like a wavetable kind of thing like that. You don't need wavetables to be very long. There's already interpolation between the samples, they're never blocky or whatever. It's going to be 512. Oh, no, I don't want it to be 512 milliseconds long. What am I thinking? I want it to be 512 samples long. That should be fine. So we're going to have a tiny little buffer of audio that's only 512 samples long, and we want it to be like an envelope. So how would you make a nice envelope-like shape? Well, you might have used like Granular Synths before, and they typically have a few different envelope shapes. They have like what's called a Hanning, or is it Hamming? They have like a Hanning envelope or a square envelope or stuff like that. I can't remember how to do half of those. I remember I downloaded some objects by someone else who's already done that, and I keep meaning to add them into this device. I can't even remember what it looked like. It was probably in here somewhere. What's all this? Laughing at Noisily Festival images. Here is a crazy bit of complicated code that generates all these nice window shapes, like cosine shapes, Bartlett, Hamming, Hanning, all these other kinds of envelope shapes that you use in granular synthesis that no one wants to know how to program because it involves loads of horribly complicated maths and expressions that look like that. So I'd probably just go and copy that code wherever that person made it. But for now, we're just going to fill in a simple Hamming window. And you can do that by doing things like this to a buffer. So luckily, when you make a buffer object, you can do things like... so let's quickly make another waveform object. Let's say... I think, yeah, buffer name, let's call it envelope. Nice. And that's going to allow us to see the waveform we're making. If we send the buffer object the message fill1, it just writes 1 into all the samples. And I think if I then say apply Hamming, or is it Hanning? We now have a kind of like buffer, envelope that's just a nice kind of like half, I think it is like half a sine wave or something like that if you think of it. So it's nice and smooth. It's got a smooth attack. It's got a smooth release. So it's not very aggressive. If you wanted to make a more aggressive envelope, you'd maybe have like more of a rectangle or like a quicker start attack and the end, whatever. Anyway, for now, this ugly thing will be our envelope. I do remember the last time I made this, it actually clicked and made horrible clicks at the start and the end, because technically this first value in here never actually reaches 0, because it's something to do with maths and sine waves and like exponentially curved things. It never actually hits 0, which is hella annoying. So I remember I actually needed to write those into the buffer. Did I use poke or did I use peak? So there's another way to write values into a buffer. So this will just allow us to hard write the values into our envelope. How does peak work? I think you just send... Ooh, I think it's expecting audio signals. Let's get rid of this then and just use poke. Basically, I'm trying to make a nice envelope which doesn't click at the start and doesn't click at the end. So I am going to do a horrible, terrible, I don't advise you to do this way of doing this until we can make proper nice envelopes. I'm going to write the first value, the very first value of this envelope. So sample 0, I'm going to make sure it's 0, because I'm pretty sure at the minute it's technically not. It's some weird value. So if I actually look at what sample 1 of this currently is, yeah, 0.08, and the final sample, sample 512, is actually not 0 either. So something to do with maths, and again, this not quite scaling off to 0 properly. It would actually not be a great envelope because it would make a weird clicky sound. So I'm going to force it to not be clicky. Which order these go in? So that's the sample value to write. That is the sample to write it in. So 0 at sample 0, and 0 at sample 5, technically 511 probably. And if I send that into now, it's effectively changed this very first sample here to 0, this very last sample to 0. And if I read that sample value, yep, sample 0 is now 0, and sample 511 is now 0 as well. So we've now got an envelope that should hopefully not click and give a kind of relaxed attack and a relaxed decay. Which is what we want. So we now want to, whenever we're playing a sample, we effectively want that sample to play with the relaxed attack and the relaxed release, so we don't get any clicks if we trigger the sample to start at different start positions and different end positions that happen to not fall on a 0 crossing. So here we've got our play object. Play object is doing the playing. It's currently not being enveloped at all. So we're going to want to mess with this audio signal and envelope it in a nice way. So what we're going to do is we're going to use a multiply object. So again, if you ever want to change the volume of anything, you're actually just multiplying it. If we want to play at the same volume, we multiply it by 1. If we want to make it stop playing, we just want to turn off. So if you turn the volume fader down to 0, we actually just multiply it by 0. So what we want to do is kind of when the sample's playing, we also want it to play brain. Yeah, we want it to multiply by the envelope. Yeah, that's what we want to do. Yeah, I remember what's going on now. So I'm going to make a wave object, which is just like a play object. It just lets you play a sample from your buffer. And we want to play the envelope that we've designed here. The reason I'm using wave is just because it play, you send it an audio signal and it goes from 0 to the length of the sample. So in this case, 5,000 milliseconds or 5 seconds. Wave just always receives from 0 to 1, which is fine for us in this case. We just want it to go from 0 to 1 and envelope the audio file. So when we if you imagine we trigger this line up here to start playing, it's going to play from 0 and it's going to go from 0 to like 5,000 or whatever. At the same time as we're triggering the sample to go from like 0 to 5,000, we want this just to go from 0 to 1, and it's going to multiply the output of our sample by this nice little curve. So while the sample's playing from 0 to 5,000, it's also getting enveloped kind of like this. Obviously this shape doesn't make sense on a really long sample, because, you know, the first, say this is a 5-second long sample, the first, you know, 3/4 of it's going to be pretty low volume. But again, this is granular synthesis. We're working with tiny little grains, and to make a grain not click on the kind of tiny short sample times we're going to be messing with, these kind of Hanning or hamming or whatever the hell it's called shapes tend to work. If you have really quick attacks on a really, really small grain, it'll still end up being such a small jump. It'll kind of make clicks and pops, which sometimes you can want. But yeah, so we can add in extra envelopes later to do different kind of enveloping effects. So at the same time we're playing our sample from 0 to 1, we also want to be running this envelope from 0 to 1. So we're going to need to get that information from our line object. And we're going to want to scale it. So one quick and easy way to do this, although thinking about it I think we might change it at some point, is kind of something like this. We're going to get an audio signal and we're going to, this needs to be a scale tilde because we're in audio land. It's scaling from 0 to the sample length, kind of. Although that's a lie, it's actually scaling from 0 to the duration. So we're probably going to need to steal that. And we just want it to go from 0 to 1. Will it work? Will it work? Let's find out. So, while the line is generating a number to control the play position, which goes from 0 to the current sample size, we also want it to go from 0 to 1, which is going to control our envelope. With any luck, if I trigger a sample, I think that's kind of doing what I like. Let's just make this do that weird funny trick again. We're going to play halfway through. We're going to play for the full duration. So it should go from sample position halfway through, 2,500 milliseconds, all the way to the end, wrap back, play back to the beginning. And that should hit 0, 1. Bang! Yeah, and it hits 1 at the right point. So if I drag that cable all the way down to here, that is going to be triggering the enveloping. So if we viewed this while playing the sample, we should see end and then enveloping the sound. And if I stop the audio for a sec, we might even actually be able to hear it a little bit. End, and then just... I'm going to fill this buffer with just plonky sounds and not my voice, because we don't want to hear that. It'll mix up between the mic. Let's go. That looks like a buffer full of marimba rather than my voice. So if we play it now. Yeah, so hopefully you can hear that as well. But this is the envelope running at the same time as the sample. So it kind of slowly fades in following this envelope shape, and then it fades out as well. Again, doesn't make much sense on long samples like this. But again, we're going to be working in tiny little grains and big grain clouds where envelopes like this make more sense. I think so anyway. I think that's working. Cool, so we got an envelope working as well. The other thing we want to get working quickly is pitch. So, how did I do pitch before? We're kind of been at this for about like 2 hours now. So I want to get this going quickly. So I am again going to dive in to my ready-made actual working version and just have a look at the pitch code rather than hitting my head against the wall for a few minutes trying to remember the maths. But again, yeah, we want to change the pitch, and in this case it's kind of like a vinyl thing. If you play like a longer duration, at the minute it would kind of slow down. If you played it a shorter duration it would speed up. But obviously we want to get to the point where, like at the minute with this little hack where it's sending the duration are the same, so it's always making however long you want the sample to play, the line goes on for that long. So that effectively always makes this play at the correct pitch, the way we've kind of hacked it together here. But you actually want to be able to use something like a nice pitch dial here to control what speed it's playing at a bit better. So I think we're basically going to want to stick something in here and like multiply it by this, which, if my brain was working properly, I could probably think through, but maybe at the minute we should just copy some code that like already does it. I think we're going to want to get this number and like have it over here somewhere, kind of thing. And we're going to want to do something multiplying it by this. Because if this is at 0, you just want it to send itself. So that's more of an addition, not a multiply thing. If this went up to a whole octave, so if this went to 12, that doesn't need to be floating point. Let's just limit that to semitones for now, rather than getting microtonal shit on the go. Oh god, why is pitch and percentage? That can piss off as well. We're going to set this to be semitone display, and yeah, it's an integer now, so that looks better. Yeah, we've got nice semitones. Next, multiplying things or adding to things. We're going to want to change this duration number, music in the background, by yeah, screw it. I'm looking at the one I made before. Duration was doing duration. Oh, I added directional thing in to do reverse, and there's also some nice randomization stuff. We might get onto that in a bit. Maybe I'll have to do this in 2 parts. Who knows? Pitch. Here we go. Yay! Expression things. So, why is pitch and 0? Oh, that's the randomization. Okay, that's fine. So, the line is coming out of line. Is this line always? What was this weird bit of maths or programming doing here? It was triggering 2 numbers. It was always making them go. Is it always making it go from 0 to 1? No. Oh, it is. Yeah, okay. Yeah, brain doing something different here. I get it. Okay, so I did this in a slightly better way, which makes sense now I think about it. This line object at the minute is going from 0 to like 5,000 or something, to decide the length of the sample and how, like what duration of the sample it's going to play for. What we're going to do is we're actually going to make this line only ever generate numbers between 0 and 1, and just like we did with the start position and the wrapping, we're going to add the duration maths to be controlled down here instead. So this is our effectively, this is just like a wrap. Let's add some comments. Make sure, make sample loop if needed. That's kind of what this bit of code here does. This is the sample start. Maybe let's just kind of clean up this code a bit. Let's get panning out the way down here. Volume we haven't done anything with, we'll do that later. That's kind of obvious because it says envelope, but that is our envelope section. This is our actual play object. Again, pretty obvious because it says play on it, but comments help. That's our little user interface thing. This is the sample wrap thingamabob. Let's clean that up a little bit. Drag it down here. Sample start. Put that down here. Ooh, cables everywhere. We'll clean this up at some point. And again, so we're going to convert this. So this is our duration control. At the minute is designing this line, and it's making it go from 0 to 5,000. I do not want it to do that anymore. I want line to always go from 0 to 1, so we can stop having to faff with this multiplication as well. We should actually just be able to play the line indirectly from now onwards, because effectively it's always going to go from 0 to 1. How can I get that to be less ugly? Like that, I guess. So this is always going to go from 0 to 1. It's going to play from 0 to 1 there. Duration. So instead of that number controlling this going from 0 to 5,000, or whatever the sample start is, instead I want the number to go here from 0 to 1, but it gets multiplied by the duration and should end up being the start length, controlling the length it's going to play. So to do that, we can chuck this here and run this into there. So whenever we trigger this, it's going to set this multiplication number. So if this is running from 0 to 1, this is going to multiply it by the sample size, and we're again going to end up with, if you're at the start 0, if this is sending 1, that's going to be multiplied to be the sample length, which would be 5,000 in this case. We're going to want to kind of get rid of this, because we're actually only going to want to control the duration at this point. We're actually always going to want it to be 1. Just like we're always triggering it to start at 0. So we're always going to want to trigger a 1. So we're going to want to get the duration. The duration's still going to be a number, and we're going to want to trigger a 1 at the same time. Get rid of this for now. So we can imagine that's happening. Kind of do it like that. Yeah, I'm sure we'll need to change this in a sec. But effectively, whenever we change or trigger a note to start, it's going to tell us what the duration should be. It's just going to go from 0 to 1. Pause the music. Has our coding worked? No, it's all gone wrong. That's fine. Duration. Start. Duration full. Let's do a quick check. What happens when we do a bang? Yep, that makes sense to me. Yep. But the line has stopped working, as if audio is no longer turned on, which it definitely is. Why would you do something horrible like... Ah, because you plugged it into the wrong inlet. That's always a stupid thing to do. Reinstantiate the line, plug it in properly. We have a sample playing from the start, ending, being enveloped. Duration is now controlled down here rather than by the number feeding into the line, and that should allow us to do the pitch a bit better. If I look back at the example I'd already made, where are we? Nope. Yep. Music. Cool. Duration. Yeah, so it looks like I was doing... Duration was just getting banged and getting joined with a 1. There's some direction code here, because if you can imagine, this line is being told to go from 0 to 1 over a certain amount of time, which is the duration. It could also be told to go from 1 to 0, which is a simple way of getting it to play some of the grains reversed. You could add grain reverse randomization and it will randomly play reversed and stuff like that. That's quite easy to add. We'll do that later, maybe, or in the next session, because I think I'm going to have to do another one of these to get a bit further. Pitch. So we're just going to copy this pitch code because working it all out is tricky at the minute for my brain anyway, and I've already worked it out here, so let's just do that. Cool, so the duration gets sent down here and is being controlled, multiplying the number there. It looks like I put the pitch directly in between the line, so the pitch is also being controlled by duration, and the sample size is involved. Oh no. So, pitch is not being controlled by the duration at all, because the duration's already setting the length it's going to play for. The pitch is just multiplying the number before it runs into the duration. Well, it definitely made sense when I programmed this before, because it's working. So what I think we're going to do is we're going to add a well, I'm going to copy this because I cannot be bothered to remember what that is. Basically, this is a little bit of maths magic, I think, which if I paste it in here is probably making the octave numbers make a bit more sense, because up here we're controlling the pitch in semitones from -48, -4 octaves, up to +48, which is up 4 octaves. But we want to convert that into something that's a bit more usable in terms of a play speed. So yeah, when we set the pitch to be 0, so no change, just play back at normal pitch, this bit of maths, or a maths expression, just sends out a 1. That makes sense. If we wanted to play an octave higher, so 12 semitones, effectively an octave, when you go up an octave, you're effectively doubling the speed at which something is playing. So if I type in 12 here, this should output 2. That's correct. If we go 2 octaves, 24, 36, 8, and finally if we went a whole load of octaves up, we'd end up at 16. That makes sense. So that kind of makes sense when you're going up, but this also works in the negative as well. So in terms of, you think about a vinyl player and play speed, when you're just playing back at normal speed is like 1. If you want something to stop playing, you send it as 0. So when we go up in semitones here, we're jumping to bigger and bigger numbers. So that's doubling the speed doubling it again, all the way up to quadrupling it. But when we go down semitones, so if I wanted to play this -12, we don't want this to be -2 or -1, we want this to be 0.5. And then as we go down to like increasingly lower amount of octaves, we want it to play longer and longer for a smaller and smaller number, but never hit 0, because 0 makes it actually stop. And we're going to add this in a sec, but what I am going to quickly need to do is go and have a piss, because god damn it, that cup of tea and drinks of water have made me need a piss. But rather than pause the stream, I'm probably just going to run and have a quick piss, come back, finish off this pitch thing so that works, hopefully really quickly chuck this inside a poly object so we can trigger it numerous times, and then I think, as I've been rambling for about 2 hours now, we'll call it quits, and I think I'll have to do a second one of these where we finish off programming the whole algorithm. But definitely for now I'm going to add this pitch thing in, and then I'm going to put this into a poly object to show you how, rather than just having one sample player, we can quickly paste this code and have like 50 playing at the same time or something, which make a nice big grain cloud. But yeah, I'll leave you with some Rob Cluse music and quickly run and have a piss and then be back. Right. Where were we? Doing pitch. Now I think about it, this does make total sense. So we're just kind of doing, yeah, like rough vinyl style repitching. We're not doing fancy, clever, time stretching-y stuff. So this number coming out of here is going from 0 to 1. We're multiplying it by the sample size, so it plays the full sample length. And we can move the start position as well later on here to make it play at different start points, which you do by addition. And we use this wrap to make sure it never goes over the end of the sample. It always wraps back to the beginning, playing like a loop. So what we're going to do is we're going to multiply this 0 to 1. So this is always going from 0 to 1. And if we just set the pitch to be 0 in semitones, it would effectively just send a 1, and multiplying by 1 obviously is basically the same as leaving a number completely unaltered. So it'd just play back as normal. But if we say wanted to play this slower, if we wanted to play an octave lower, if I sent out minus 12 semitones, this now sends out 0.5. So what we're going to do is this line that's running from 0 to 1, because of this multiplication over the same duration, it's now actually going to only run from 0 to 0.5, or it's only going to run halfway through the sample. So we're not doing any clever time stretching-y, phase vocoding-y algorithm stuff in here to make the duration and the pitch not change or be like linked. At the minute, whenever we change the pitch, we are effectively going to change the duration, or at least the end point. We set a duration and the sample will play for that length. But if we half the play speed or the pitch, it's obviously only going to play half of the sample, but it will still play for that duration. So, having looked at how I thought about this before, and with it actually making sense now, it's not that confusing, is it? There's just this horrible bit of expression-y stuff in there to make the semitones convert into nice kind of sample playback. I always think about it like a vinyl player kind of thing, numbers. But yeah, makes sense. So we just chuck, you can sack off this sample size stuff, no one needs any of that. We just send that straight into here. So whenever we change our pitch, so let's just set it, let's do, where's the waveform? It's something like that. I could probably put this up here, why not? Ugly cables everywhere. Pitch 0. Start point at the start. Let's make this shorter just so we can test it out. Let me pause the thing quick. Music. Horrible distorted thing. Anyway. How does that sound? Sounds fine. And yeah, you can hear it's being enveloped as well. And now if we change the pitch, so you can hear, hopefully, there we've got no pitch change. If I increase the pitch by a whole octave, hopefully you can hear that it does sound an octave faster, an octave higher. But obviously what it's also doing is effectively it's doubling the playback length, because to play an octave higher, it has to play 2 times faster, and it needs to play for the same duration, because we haven't made a fancy time stretching thing that's keeping pitch and sample end the same. So at the minute it ends up actually playing more of the sample. So if we set it at 0 pitch, you can see the duration here, it's set to 1/4, so it's only playing like that. If I change the pitch loads, we can end up playing it many times, or we can end up playing it really slow. But it only plays a tiny portion of the sample, so try and move that a bit. Yeah, a little bit more. A little bit longer. Ooh. Some nice low tones. Super stupidly low. Not even a useful point of the sample. Too low to even hear with my headphones on at the minute. Anyway, that is a basic pitch thing working as well. So we can control the start point of the sample. We can control how long the sample plays for that's not, obviously, as we can see with the pitch, it's not a true sample endpoint. It's just a duration for the amount of time it's going to play for, but that duration is specified in percentage of how long the sample is. We can also re-pitch it, so every time we trigger it to play, it'll play at a set pitch. And the way we've set this up, using these kind of objects here where it stores the number, that's kind of to stop any glitches. Basically, you can only change the start, duration, or pitch of every new sample. Once a sample is playing... Ooh, that didn't work for shit. Messing with that doesn't do anything until you next trigger it, which is what you want with this kind of engine. Otherwise you can end up with glitches if you start trying to change or automate the pitch midway through playback of the grain. If we were making a longer form looper, you might want that. Because this is generally going to be designed to play back very short grains, and the way granular synthesis works, generally, basically, you don't change how the sample's playing midway through it playing. You just wait to the next sample, and that's when you actually mess with it. Cool. Start, duration, pitch. Down here somewhere we have a volume. We have a broken panning algorithm, which is pissing me off a bit, but I cannot remember why that wasn't working. Is this left? Let's try and listen. No. Yeah, it just definitely isn't working, even though I'm pretty sure we near exactly copied maybe? No. Ooh. Ooh. So with that not being a audio rate object, for some reason now the panning works. If we're at 0, we can see these are both equal panel. This is the left channel, this is the right channel. They're both the same. If we go down to -1, you can see this left channel is now up, the volume's up full, so effectively that's fully panned, and the right hand channel is at 0. If we go the other way, we should see 0 point up to 1. We've now got the right hand channel turned fully up, the left hand channel turned fully down. In other words, panning is actually working. I don't know why the hell that not being a... I mean, surely that should work. Why would that not work? Yeah, it just doesn't like that at all, does it? I mean, I'm pretty sure it should like that. Screw you, panning. We will deal with you later. But for now, yay, this should pan right. This should pan left. Oh, well, that magically started working now. So we'll just leave that as it is. So we've got a few parameters of the algorithm, of this sample playing engine that we're going to want to control. At the minute it's obviously just a single kind of sample player, so it's not that exciting, or useful for what we want. What we want to do is put this, duplicate it many times, so we can play many grains at the same time. You could put this code in a little shell, which is called like encapsulation or abstraction in programming terms, and we could copy it loads of times. Luckily, Max has a way for us to do that a bit easier. And yeah, I don't think I'm really going to be able to use... Oh, I could make some really complex version of this later. For now, we're going to get rid of our nice display because this isn't going to work with what we're going to do. we're going to want to get all of this code and chuck it inside like a little house, and we're going to want to be able to make multiple versions of it and trigger them all. And we're probably going to want to trigger that. Well, that only needs to change once, but let's just make it be triggered then, because I can't be bothered to program that quite yet. That gets triggered when pitch changes, yes. This gets triggered when the duration changes. That gets stored when start changes. This is all good to go. Okay, so what we're going to do, we're going to put this inside another bit of code and trigger it from outside where we can make numerous versions of it. Let's do it. So this is our Max project, Max for Live device project, sorry. At the minute we've only got one copy of this sample player. We're going to make multiple of them to make it more interesting. Add a new file. Clicking add this should add new file. Should store it in... Oh, I haven't even saved this patch. I need to do that. God damn it. Yeah, save your patches regularly. Don't forget to do that and then have them crash. Yeah, desktop. And granular mess. No, not there. There. Let's just call it that for now. And now, back here again. I'm going to make a new patch within this granular mess Max for Live device project thing. Oh, that messed it up. And I'm going to call it grain, because this is going to be the single grain player. And it's going to be in a poly object. Oh, screw it. Let's call it grain. So that's made us a new patch, and I can copy all of kind of this into it. Yeah, that's what I want to do, from like there all the way down to here. Quickly just add in some placeholder things. That's actually a floating point, so these don't get messed up. Thank you, thank you, thank you, thank you, thank you. Copy all of you all the way down to here and paste you in there. Cool, so this is our new little snippet of Play Engine code in its own little patch. Yeah, if we're not familiar with why we're doing this or what we're doing, maybe I will do like an introduction to Max video one day where this all makes a bit more sense. But for now, what we're gonna do is turn this into a poly object. Poly stands for polyphony in this case. It's a way in Max where, just like with polyphony, if you imagine you've made a nice synth engine and you want that synth engine to happen polyphonically, you need to be able to make that same synth engine be triggered every time you hit a note, so you can play chords and stuff like that. So kind of like that, we built a little sample little sample engine. We want it to happen many times because we want it to do nice granular stuff. So we're going to have an input, and these actually need to be tildes probably. Do they in poly? They need to be tildes? Let's say they do. I can't remember. Output 1, output 2, and in 1 for data, We want to send it the message play. I want to be able to send it the message start position. No, screw it, start will do. Duration and pitch and volume and pan. Whenever you receive play, do that. Whenever you receive start, change that. Whenever you receive duration, change that. Whenever you receive pitch, change that. Whenever I receive volume, I'm gonna have to work on that. That's not quite right. And whenever you receive panning, change that. So now we have a little enclosed, oh god, what's going on there? Little enclosed sample voice that we can chuck inside a poly object. So if I come back up here and I make a new poly object, poly tilde, and I call it the name of the patcher. Was it grain? Did I call it grain? I think I called it grain. Yeah. So now we can open up this poly object, and this poly object has all that sample code we chucked in. If we leave the poly object just like that, and for now I'm kind of gonna delete these. I'm gonna get rid of this outside of the poly version. Oh god. All of that. Chuck it out of the way. Grab the plug out object. Chuck the grain into the poly. Oh, music's not playing. I just realised it's just my voice sounding weird. Cool. So all of that big chunk of code that was previously over here is now just living inside this single poly object. We can open it up just by command double clicking on it. And if we just sent this the message play, and let's grab our volume control as well, why not? What we should get is it doing just what it was doing before. Or not, probably because a load of these values need to be instantiated, I'd guess. So what if that's sample start, that's duration, pitch can be 0, that's fine, volume needs to be 1, panning can be 0. Will this work? Yeah, cool. So what we've got now is all of that same code that was here, just living inside this nice little single snippet, out the way, living inside its little poly life. The good thing about that is when poly is just on its own, like it is there, just sitting on its own in a normal little poly object with no arguments, it's just a single sample player. Why is... oh god, it's because the play message does something special to poly, is that why? It's probably why. Why is it looping? Stop looping, you're not supposed to loop. How do you even loop? You're a line object. Line objects can't loop, can they? We'll figure that out. Anyway, so that's just going to play a single engine, single sample engine, and it'll just play once. Poly, we can chuck that bit of code into a poly, load it up, and we can make it happen loads of times. So if we make poly grain 50, what I've done there, just by typing the number 50, is I've made 50 of these sample players. So there's now 50 of them. So rather than just one happening and one happening at the same time, we've now got 50 of them, which is what we want. Because then we can make really dense grain clouds, basically. So we want to be able to send each of these individual poly messages, poly objects, the message play, we don't want them to all play at the same time. We want each of them to play individually when they're triggered. So basically before, if we ever sent a play message, it would start playing from the beginning again because we only had one engine. Now that we've got kind of 50 sample players, we can play them quickly and they'll all play for their full length, and you'll get these dense clouds of numerous things. Kind of like, yeah, with polyphony, you can play like the same thing loads of times on top of each other. So to do that, the poly object kind of has a load of stuff to do that built into it. So when you've got a poly object, you can send a message to because we've got 50 sample players in here, we could send a message to sample player 1, 2, 3, 4, 5, whatever. What we can also do is use the built-in stuff in poly to kind of make sure it just sends to each one after the other, whichever voice is free. Basically, whenever we send it the play message, it will send automatically to the next free voice. That's kind of a clever thing poly does, and it does that using the note message. If you send the message note beforehand, it does a nice clever thing of only sending to the next available voice instance. So if we just add the word note before this play message, it should only send to the next free voice. If we go inside here, we need to find a way to tell the grain object, or this poly object in this case, when it is busy. So when a note's playing, we need to say that sample voice is currently busy. When the sample finishes playing, we want to be able to tell it it's finished, so it's free to receive another play command. When you're inside a poly object, which we currently are, there is an object called this poly that allows you to do these things, basically. So I think what we kind of want to do is, yeah, so whenever you receive a play message, probably the first thing we want it to do is tell the poly object that we're busy. And you do that by sending the message 1. So whenever you receive play, start being busy and make sure you can't receive another play command until you've finished playing the whole sample. And luckily the line object, which is what's controlling our playback, whenever it's finished, so this basically controls the playback engine. It goes from 0 to whatever the duration of the sample is. When this stops running, we know the sample has played back its full duration. So luckily line out has an output that sends a bang whenever that's actually happened. So what we can do is we can add a trigger 0, and so whenever we receive a play message, we tell the poly we're busy, don't send us any more play messages. Whenever the line has finished, so the sample playback has finished, it sends a 0 to this poly and says I'm now free, so you can send me some more play messages again because I'm done playing my last sample. The only other thing to consider is having 50 sample engines on all the time is obviously a bit more CPU usage, especially if you get up to having hundreds or whatever crazy granular stuff you want to do with 100 grains playing at the same time or whatever. So what we want to do is to save CPU, you can turn off all of the DSP, or the digital signal processing, for this poly whenever it's not in use, and you do that by sending a mute message. So we basically want to do that, the inverse of this. So whenever, yeah, so if I take these two numbers here and I just invert them, we should get the... what the hell's that? Get rid of that. Prepend the word mute. I have to play some music again. Yeah, so just a 1 or 0 turns it on or off. And if we do invert the numbers again, is this going to work? It should work. It better work. So whenever I send the message that I'm currently playing, turn mute off, tell this patcher we're busy. Whenever I have finished playing, tell this poly we're free again and turn the muting on so we save CPU when we're not doing anything. So that little bit of code there should allow these voices to tell the synth when they're busy or not, so we can make polyphonic stuff easily, and it should also allow us to save some CPU by muting and unmuting the patch. Now that's kind of that dealt with. The other little job we want to do is we want to be able to send the start, the duration and the pitch to all of these poly objects at the same time. We don't really want to access them individually. We want to send that message to every voice at the same time. And the next time it's triggered to play is going to take into account what the start and duration and pitch should be. Oh, and panning. Get panning involved as well. So this is nearly actually a usable granular synth. Only took a bit longer than I thought, but there you go. So the note object being sent to a poly makes it just do some clever stuff and work out which voice is currently playing. If I just send it any old message, does it go to everything? I think I need to send it a target message first. I'm trying to remember how poly works. I swear it's a target message. Am I wrong? Oh, it is target. It's an attribute. Right. So what you can do is you can send... you can just send a message to a single instance of the sampler. So we could just be changing the start position of a certain sample engine or something. So if you had a polyphonic synth and you wanted to play one at a certain pitch, you know, if you wanted to make chords, but you had a full version of the same synth engine, and you'd send one of those voices to play at a certain pitch, another one of those voices to play at a different pitch, yada yada. That's how you kind of make polyphonic synth engines playing at different pitches. In our case, we actually just want to make them all be at the same pitch, roughly, but it's only the next time they play, they'll then play at that pitch. So to do that, we send the message target 0, so that makes it send to all of them. Is that correct? Help file, tell me the answers. Target 0. The message to blah 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 blah, blah help file blah 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 blah. Message target 0 sends to all instances. Yes, that's what we want. So whenever I receive a message here, I first want to trigger target 0 just in case anything faffy's going on, and then I want to actually send that message to the poly object. Start, because we used a root object inside our granular object to control the start and all of that stuff, using routing rather than you could either have multiple inlets here, you could have like 6 inlets or whatever, one for each thing, or you can just prepend each message with a word, play, start, duration, pitch, volume, pan. That means here, whenever we change this start dial, we want it to add the word start, so you end up with that. There we go, that's a bit better. And that's getting sent into the poly. whenever the duration changes, change the duration. Whenever pitch changes, change the pitch. Finally, panning. Ooh, go away. Yeah. So these should all now get sent to all instances of the sample engine. They should all have some audio still in them, don't they, somewhere? Yeah, that's what they've got in them. That's fine. And we should be able to send a play message. The play message should get sent to whichever voice is currently free and trigger it to play. Will it work? Always a fun bit of writing a load of code without kind of testing it, just knowing what you're doing, hopefully, is you might actually just press play and it'll do nothing. Oh god, what is that? Start position 0, yes. Duration, yes. Pitch 0, panning 0. Ooh, yeah, panning's doing something. Play. I don't like the look of that. Is it because of this? It is because of this. Yes, yeah. Earlier, I remember annoyingly exponential curves, blah, blah, blah. This function never actually reaches 0, so I had to do this ugly thing. We'll make better envelopes one day. But now, I have a sampler. I can trigger it to play, and it will trigger. But I can also trigger it to play multiple times. So there, we're triggering like loads of them to play on top of each other. We can have 50 playing at the same time. So that's how you can make really dense grain cloudy stuff. So if we get back to our metronomic pulse playing grains and set it to play 10 times a second. Oh, it does nothing because we actually need to send the play message, don't we? We're now getting loads playing at the same time. Tons. Ooh. Wow, it's doing stuff. And that's starting to sound. That's starting to sound a bit granular. You'll notice though, the last thing we're going to do in this video, before I shut up and go away, because this is taking a bit longer than I thought, is if we just trigger them all to play at the same settings, at the same time, on top of each other, it's not that interesting. It's more of just a weird glitch, loopback effect that's not far off what you can do just with a simpler or a looper or something relatively simple set up in Ableton. What we want to do is we want it to randomize a bit so we end up with giant grain clouds. So you'll notice when I trigger that to play and I start messing with the start position, that's when it kind of starts getting a bit more interesting and granulary. So what we need to do is we need to add in randomization for some of these parameters. So every time it triggers, it doesn't just trigger the start at the same position, it triggers it slightly randomized. Because of the time, I'm probably not going to do that to all of them on this session. Maybe I'll do that at a later one, but I will do it for one for now. So, as well as for each of these parameters having a actual setting, so we want to set the start, the duration, the pitch, yada yada, what we want to do as well is we want to have a randomization amount. So let's grab a live dial edit it a bit. What we want to do is we want to have a start random. There's no way start random is going to fit into there, is it? Would you just have the word random for all of them? I mean, I guess you could just put like a live like number underneath all of them. That might make a nice UI, maybe. What? Don't tell me that. Live dot number is a thing. No, it's not. I'm totally wrong. Numbox. Wait. So in our UI, if you imagine, we're going to have all of these parameters: start, duration, pitch, pan, volume, direction. We can add in another session, and for each of them, we're going to want to be able to randomize them, so we can make our dense grain clouds. And so we're going to have a nice dial, and then underneath it we're going to have a little number box, and that's kind of the randomization amount for each one. So randomization, you again want to be a percentage. You want to be 0 randomization is none, up to full randomization. Don't really need to mess around with making these things pretty. These are commands basically just set what number these parameters are in the automation lane, but we're obviously not using that for the minute, so I'll just make one for now. So for now, let's do start randomization, and I'll call that start random, because again our code isn't up here where I can mess with it anymore. Our code is now inside the poly object. So what we've ended up with is that. And for each of these, we're also going to have a little kind of random amount that we can control. And we can dial in from 0 to 100. No one likes 0 to 100. Let's just make it be 0 to 1. And that is now getting sent in to our little poly chunk of code inside this grain. So whenever I change this dial, and if you imagine we had a nice little user interface where we had the start with the randomization amount underneath it, and we can have nice waveform views, and all of the grains can be triggering this playback position thing, and we can have recording. The other things I'd probably do is, at the minute we can record and loop into the buffer, and we can play at a specific start point. You could do stuff like have transient analysis, so you only whenever you say you're recording and you hit a big transient, it could automatically set the start point to play around that transient. So that'd be good if you were playing like live guitar or something into it. As soon as you strummed a chord or played a note, it would start granulizing around that start point and kind of granulating it. Especially if you added in some randomized chordiness, you can kind of get harmonization and stuff going on. But we're not going to get into that in today's video. That would take a bit too long. For now, we're just going to finish up by adding randomization. So we open up the granular bit again. We're getting one more number now, as well as getting that's the original code, as well as getting the start position. We are now also getting start random. Oh god, it's going to reorganize all of these, isn't it? Right. Oh, we'll do this in a better way in the future. For now, this will do. So those are all still going to the right place. We now have an extra input for this start random control. And for now, I'll just chuck that like that. So the start position is being controlled down here. We send in the start position we want. It gets stored, and whenever we bang to play the note, it gets what the start position should be and starts playing from that point. What we want to do is we want to be able to add a bit of randomization to that start number, and there's a handy object called random that basically just does something near there, it just generates random numbers, or pseudo-random. So whenever I hit this bang, it's going to generate a number between 0 and 1000. Or 0 and 999, maybe technically. I can't quite remember how it works. What happens if I do that? What happens if I do this? Yeah. Yeah, it's from 0 to 1. So yeah, if we do that, it's going to generate random numbers between 0 and 999. Boom. So what we want to be able to do is we want to be able to mix in a bit of this random chaos with this sensible start position number. Let's think through the maths of how we do that. What we want to do is we want to have our sensible start position number come in here. We want to have our not sensible random number here. And we want to mix these together. We want to multiply. Yes, because we also have a percentage. We have a randomizer percentage amount. So this is our random number, and we multiply it by our random amount, and that defines just how crazy we're getting. So again, this multiplied by 0 obviously does nothing. If I turn this up to 0.1, we're effectively generating relatively small random numbers, just between 0 and 100. If I go all the way to 1, we're going to be generating numbers fully between 0 and 100. We also want to scale this down to be in the 0 to 1 range, do we? Maybe? Oh, we technically need to scale it to be within the sample size. Oh no, we don't. Yeah, this receives numbers from 0 to 1, doesn't it? So we want to get this into the 0 to 1 range. So multiply, if it's 1000, that. I've been doing too much kind of math today. God damn. I am not good at maths. Cool. Yeah, so that's now just generating numbers between 0 and 1 rather than between 0 and 1000. This is multiplication below is controlling our amount of random. So turned up to 1, this is going fully between 0 and 1. By going down to 0.1, we're just getting tiny little differences. And we then want to add that onto our actual proper start position. So out the bottom, we effectively get a number that we can dial in craziness to. So if we set our start position to 0.5 and the randomness is at 0, nothing's happening. If we start dialing this up and adding a bit of chaos, need to trigger that happen at the same time. Ugly coding for ugly hours of the evening. This now should start adding a bit of chaos. So we're still pretty near 0.5. We're just going a bit wonkily above it. That's the other thing. This is currently always adding to 0.5. It's not going either side of it. We could change this maths here to actually make it go either side. Maybe we do want that. Maybe that's what we want. Maybe. I'll think about that later. Cool. So if I turn all this craziness all the way up to 1, and then I start banging this, yeah, we're actually going all over the place with chaotic numbers, which is good. That's what we want. Dialing up random should do random craziness. That is the point of it. One thing we probably want to do is we want to make sure this never goes above 1. So we could again modulo this to be 1, I think. That should make sure, even if we dial up the craziness all the way to 1, we should never end up going above. Yeah. Maybe. Anyway, yeah. So now we've got the modulo here, we're never going to go outside of the bounds of our 0 to 1 range, which is where we want to operate. So, adding this to the code, the start position comes in here. That replaces that. Whoop. The randomness comes from here, and that replaces that. This actually wants to trigger into here. This can move out of the way a little bit. That needs to go there, that needs to go there, that needs to go there. And we want to trigger this random to happen every time a note plays. So what I'm going to do here is do another little quick hack. So what you could do is just basically whenever you're going to play a note, you want to generate all your random numbers. So it's going to be random the next time it plays, or not random if you turn up random totally off. But what I'm going to do, because we're going to want to randomize everything and you'd end up with cables going all over the place, I'm going to do one further little max hack, and I'm going to use a send object. So the send, or the S object, allows you to send messages around patches or patches without having to connect the cable. I'm going to call it setup, just so whenever a note plays, we first want to do some setup before we trigger the note to actually play. And you may remember previously in the other patch I talked about this hyphen hyphen hyphen, which generates a random number. The random number is specific to this patch, so we could make 5 copies of this granular device on 5 different tracks. We'd end up with each one having its own specific number, and that specific number would make sure the samples in each thing never got overwritten, yada yada. Within a poly or a specific patcher, we can actually generate a further random number that's specific just to this grain or just to this voice. So this voice, voice number 1, has the random number 1184. Every other voice of this kind of polyphonic grain thing will actually have a different number. So it's only when this specific voice number 1 gets told to play, this setup object is gonna get sent a bang. Yeah, and we're gonna receive it here with the same name, and that's gonna trigger that randomization to happen. Now, with any luck, if I close this and I stop the music, I should be able to trigger our granular engine to start. I might need to reset these parameters. Yeah, oh god, and we've got a cacophony of exactly the same start point note being triggered. But if I add in some randomization, it will do nothing, or nearly nothing. That's not what we want. Why are you not being crazy enough? Be more crazy. Let's check our code quickly. Maybe it is doing what I want and I'm just being silly. What is coming in here? Oh, it might be ages between this voice triggers again. Let's quickly save this, turn this off, and go back to only having... Oh god, what are you doing? Only having 1 grain. So I've just reset this to only being 1 voice effectively. Reset all these controls. Duration 25, pitch 0. We could set defaults probably in the code, I just haven't done that properly, which is probably why this is happening. So whenever we now trigger a play message, there's only one sampler that it's triggering. And if I have a spy on what's going on here, you should be getting banged pretty regularly. Yeah, every second you're getting banged. Aha! This is all wrong, isn't it? You want to go into the cold inlet because you just get stored. You actually get triggered by this. And now if we increase random craziness, every time this sample gets triggered, it gets a different sample start time. If you can see that's happening now. Quickly, I'm going to add one more thing before ending this video. I'm going to add in pan random, because that's always fun. Random panning, we can pretty much copy this same bit of code, I think. Ooh, let's do it properly. Code, 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 code. Same setup's going to trigger it. Same randominess happens and gets triggered. That controls the amount of random, and then the amount of pan. Which one are you? Are you panning? You are panning. So let's get you all the way down here. And what happens is you actually go into here. And technically this is going from -1 to 1. You're going only from 0 to 1. Are you? No. Maybe? Oh, there needs to be a tiny bit of maths here because you don't want it to pan to quite the same thing every time. At the minute it'd only go above and you want it to go between -1 and 1. Okay, last bit of maths for tired brains. We get our randomization amount in here, which is 0 to 100. That makes sense. We want to add a random number to whatever the value is in here. We scaled this random number to be between 0 and 1. If we actually... Come on, brain. Right, let's stop this playing for 1 sec. Go back to music while I maths this and then finish. So, last bits. Yes. Yeah. So, imagine we have a number. It is between -0 and 1. We want to make that go between -1 and 1. So at the minute, if we go 0, it's 0. If we go 1... Oh no, it's 1,000. That's of course what's happening. Remember, we actually want that to be different, don't we? What happens if I do that? That's going to be totally wrong. That's going to be 1,000, isn't it? Okay, screw this. Scale. Scale saves us actually bothering to think about maths. Scale between 0 and 1,000, which is what it currently is. Instead, we want to go between -1 and 1. Boom. Sod maths. Use scale. And now we add those two together. That should also give us random panning, which really helps make the granular engine sound a bit better. We could also add random volume, yada yada yada. We'll do that later. Random pitching, random durations. All these things are now possible. One more control. Bang. Pan random. Yee. With any luck, I can now pause the music, save this. If I just generate this with one voice, start, duration, pitch, pan, all as expected. If I start, are you triggering at different start points? Yes, you are. Are you triggering at different pans? Yeah, why are you always to the left? Oh, that was a tiny bit to the right. Yeah, so cool. We've got random start position and we've got random panning. Starting to be possible to do granular stuff and it to actually sound interesting. Let's get away from having just one voice. Turn off. Let's go to having 50 again. Why not? 50 grains at the same time. Save. Reset parameters because we haven't bothered to set up defaults properly in the code. Come back percentage sign. 25. Pitch 0 for now. Pan 0 for now. Pan random 0. 0. Happen 500 times. 5 milliseconds? 2 times a second. No. More times. Cool. So basically we've got a sample engine. It's triggering 4 times a second. Sounding just kind of a bit of a boring loop. So, turn up start random. Now it's starting to play at different times. So we're actually getting some kind of more interesting, it's less rhythmic, it's more grainy, cloudy. And then we turn up pan random. Now we're getting some nice randomized panning. Now let's crank up them grains. Let's mess with moving the start position a bit. Oh yeah, that's granular. Oh, I fucking love granular. We could also add like a automatic start playback. You can set the duration really small and you could make it kind of automate this style. So it's like playing through the sample but in little granular chunks. Okay, took a bit longer than I thought. Probably should have looked at that patch I'd made before, so I remembered how to make this without faffing around. But that's part of the fun, maybe, hopefully. And that's part of, I think, what we're going to do in these videos, if I carry on doing them, if anyone found them in any way slightly useful. So, we have made a granular synth thing. That sounds pretty granular to my ears. And we could crazy up and add even more randomization to all other parameters is what you probably want to do. I'd probably want to add loads more envelopes, so you can change the envelope. I'd want to be able to load in samples, like drop-in samples and have that load it into the buffer and change the sample size. I'd really want some transient detection, so when you're recording into the record buffer, if we were doing this as like a live stream, so it was live granularizing my voice, which I guess you could kind of do something like this. But yeah, so whenever I said a word, it could like just granularize that part of my voice. That'd be kind of fun. So yeah, I'll probably add in like transient detection. See some other stuff like that. And you could also have it be triggered by a keyboard. So at the minute it's being triggered metronomically. You could add in some chaos, so it only randomly triggers. You could have it trigger when you press keyboard. So if we change this into a MIDI device, you could obviously, every time you press a MIDI note, it could either trigger a single grain or it could turn on the grain at this note, and you could use the velocity to change volume and the pitch on the keyboard to change pitch. God, yeah, there's just loads of stuff you could add to make this like more of an all-encompassing, fun little granular synthy thing and a bob. And yeah, it does really basic repitching. If you wanted to add like a time stretching algorithm in it, rather than just this basic repitching, you could do that. Yeah, maybe we'll do that in another session. Maybe I'll just do something different next week. Maybe slightly more, a tiny bit more planned, so it doesn't take quite as long. Keep it to like 2 hours, 3 hours max, maybe. But yeah. Grains. Yeah, I think we got that working now. So I think we'll consider that done for today. Anyone still alive, listening to me rambling, thank you. Maybe you learnt something, hopefully. Maybe I'll make the rest of them kind of more thought through. Who knows? Yeah, and maybe next time we'll do a different topic. I'll post something up about a random other topic we want to cover. I'd like to do more on Euclidean sequencing, make a cool Euclidean rhythm sequencer. I think I did that a while before, but didn't get it fully working. Whatever else, yeah, we'll think of some other ideas. But yeah, thanks everyone for tuning in. Hope it was somewhat informative. Let me know what we should do next time, and we'll do it. I'm going to go have some dinner now, because I didn't think this would take so long. Well, thank you guys. See you maybe in a couple of weeks. Have some grains to end it. Have some grains. 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 And we're done. See you in a few weeks. Thanks.